In this video, we are going to do example 3.6.5. A contour plot for a differentiable function f of xy is given below. We are asked to draw the path of steepest ascent to the maximum from each of point P and point Q. So let's take stock of the contour plot. We see we have level curves drawn, and that these are the values, the z values, of each of the level curves. And so we can imagine a surface which is hiding down below. I'll show it in just more clearly in just a second. But these values are descending. So we can imagine these values descending to the center here where we will have the minimum value. And these values are getting bigger and bigger, and you can imagine these circles getting smaller and smaller to a maximum value. We are asked to draw the steepest ascent, which should make us think of the gradient. The path of steepest ascent, well, the steepest ascent, we remember the gradient points in the direction of steepest ascent at any point. So what the path of steepest ascent is asking us to do is always move in the direction of the gradient. How do we know what that direction is? Well, we remember that the gradient is always perpendicular to a level curve. So let's start at P. We want to move in a direction which is perpendicular to the level curve. We want to start here and end up here, always moving perpendicularly and always, therefore, following the steepest possible ascent, because that is what the gradient does. So we come down to the next level curve and we need to meet that at a 90-degree angle as well. And we continue, meeting the next level curve at a 90-degree angle, and we do this for every level curve until we reach the maximum point. So this path of steepest ascent is something that is used very often in optimization to search for maximum values. Now, depending on the function surface, it's not guaranteed to always find a max. But when it works, it finds it quite easily. Now Q, from Q to the maximum, right, we want to start at Q and head up to the maximum, traveling the same way, always perpendicularly. The path of steepest ascent you see from Q, well, that's much more direct. So if we take a look on the function surface, there's a representation of what it looks like. Here is our minimum value, right? Our minimum that was in here. Here is our maximum that was there. And if we want to draw in those paths, we can imagine Q being somewhere here-ish. Let's say that's point Q. And point Q to travel to the maximum basically just did this. The path in green to the maximum is represented on the function surface here. Whereas point P isn't quite so close. Let's point P maybe here. And P to get up follows the steepest path the whole way, but that takes P sort of this way to get to the maximum. So there's two paths that are drawn flat on level curves. You can visualize on the function surface looking like this.